Okay, so this is my screencast for my Maths C, my final Maths CA for second year. The first two graphs here, part one and part two on task two, represent examples of straight line motion. In the second graph, you see it's a straight line, and it cuts the y-axis at 2 here because y equal to 2. If this was equal to 3, it will cut it at 3. If it was equal to 2.5, it will cut it at 2.5. And it's 0 too because sine has a value of 0. Like there's no number in, like t doesn't have a number, there's no number in this bracket, so that's why it's 0 too. That's why the line that's why the straight line motion here cuts the graph at 0 2, x is 0 and y is equal to 2. This is a vertical sine wave. The y-axis goes up in 0.01, so 0.01 up until 0.1. As you can see here, that's what the y-axis does. Now the sign here for x controls this type of movement. Was the sign moves between the 2 points, kind of zigzags its way across the points to get this vertical type wave type movement. Yeah, so as sine is, if you have no value for t in this bracket, sine will be set to 0. Well, cos it will be 1. Cos will, if there's no value for t, you just leave it as cos multiplied by t. It'll be set at 1, and that's why it starts at 1 on the y-axis here, because you're saying y is equal to cos, and so cos always starts at 1, and x is equal to 0 here for the first value, so 0 1 0 1, and it goes down the points then. So at 0.01 it goes to approximately 0.5. So at 0.01 it goes to 0.05, which is 0.01 is roughly about here, and that's 0.5. Then 0.02 is here, and it goes to minus 0.41. And then because there's no sign here, the x is just here to represent the values of the x-axis, the increments of the x. The x-axis, the cos is causing this wave type of motion. Now, if this was sine, if you had yt is equal to sine t, sine starts at 0 and goes the opposite way. So instead of starting at 1 like cos does and going down, sine starts at 0 and goes up and then down and then up and then down. But because it's not sine, it doesn't start at 0 and it doesn't go up, it goes down. So cos always starts at 1 and goes down. Sine always starts at 0 and goes up. In this case here, the center, because the sine starts at 0 and cos starts at 1, the center of the circle is going to be 0 1. So the radius of the circle will always have the radius of 1 on both the x minus 1 and 1 on the x-axis, and minus 1 and 1 on the y-axis as well. In this case now, the circle is 0 2. The center of the circle is going to be 0 2. Again, just like the previous example, instead of having 1, it would be 0 minus, it'd be 0, it'd be 2 and minus 2 on both the x and the y on the y-axis, because you're just multiplying cos by 2. So this, in the previous example, it's equal to 1, and now in this example it's equal to 2 because it's 2 by cos, so 2 by 1 is equal to 2, and 2 by 0 is still 0. The number in front of the cos and the number in front of the sine will always dictate the radius of the circle. So if these two numbers were 3 and 3, then the circle will have a radius of plus and minus 3 on the x-axis and plus and minus 3 on the y-axis. Again, 5 multiplied, sine is 0 and cos is 1. 5 multiplied by 0, 5 multiplied by 1, just like the previous example, except with 5 instead of 2. And of course, the number that you're multiplying by sine, the number you use to multiply by sine is equal, the number you use to multiply by sine before the sine and before the cos dictates the radius is all again. So it's going to be 5 and minus 5 on the x-axis and 5 and minus 5 on the y-axis. Again, same the previous example. The 5 in front of the sine, 5 by 1 is 5. 5 by sine is 0, so 5 by 0 is 0. Center of the circle, 0, 5, 0, 5. Plus and minus 5 again on both the x and the y-axis. 5, 5, and 5. Now the 3 inside the t, that's the distance between the 2 points. So that would be minus 2.75 and 4.17, and then that would be minus 3.8. So it's roughly that's the distance between these points. The higher the number, the higher the number inside the higher the number inside of the t. So if these are both 70, then the points would be placed tighter together. Yeah. Excuse me. And then the sine. Oh, sorry, not sorry. The higher the number here, the less and less points will appear on the circle because they're both 3t. The 3 is both inside is being multiplied by this value of t here inside the bracket. There's less points, and as the number is less and less, so 2. In this example, we have 2. That's twice as many points as there is on the previous one. So as the number inside the bracket inside the sine bracket in here, as that number increases, the less and less points there is. So 4t and 4t will have less points than 3t and 3t. Another example of straight line motion, excuse me. There's plus pi divided by 2. Now, the only reason why pi is there is because I copied and pasted it from here. To be honest, I didn't know how to use the pi function on my laptop, like on Excel. So I just copied and pasted that into the cell here and here. So when I was doing this, I used 3.14. So I had cos and then brackets equals cos brackets t, so it'll be 0 plus 3.14. And I probably went into too much of a step size. I probably went into too much of a step size now on this one. That's why it has so many points along its axis. And it starts, as you can see, 0,9999 and minus 0,9999. That's the two starting points for the line. So x is 1, y is minus 1, x 1 minus 1, and then it keeps going down to almost again roughly minus 1, 1, minus 1, 1. So that's the starting point, and then this is the ending point. I went into sizes. I started off 1 to 10, then I went into 0.5s just on the circles just to make them more smoother. But I probably did too many steps for that straight line one. Again, the same with this, the same with this circle here, because these two values for sine and cos, like the previous examples, they both had 2 in front of them, which controls the radius of 2 and minus 2. They both had 5, and it was plus 5 and minus 5 in both axes. Well, these don't have numbers. You're not multiplying cos and sine by a number, and because of that, sine, again, like I said earlier, would be 0. So that would be 0 multiplied by t plus 3.14, and that would be 1 multiplied by t. So 1 multiplied by would be 1 multiply whatever values in here. So this causes is 1, so that means that you can't have, like I said earlier, you can't have a circle that's 0, that's 0 0 minus 0 minus 0. It's that's why it takes the cos value and it has 1 1 minus 1 minus 1 on both the x and the y axis, like I've mentioned earlier. And again, I probably went in far too many step sizes for t. That I had to have quite a lot of them to close the circle because there was gaps. But it's the same again. Now the number is outside. The +2 and the -3 here is outside the bracket. Like all of the previous examples, these numbers have been inside the bracket. So t is being multiplied by whatever number instead, but multiplied by -3, and t is multiplied by 2. But t is not being multiplied because these numbers -3 and +2 are outside the brackets. So instead it controls the center of the circle. So you're going to have a circle with a center of -3 + 2 x-axis, -3, there's the center of the circle, +2 on the y-axis, -3 + 2. If the numbers are on or before this causing the sign it's controlling, if the numbers are before the causing the sign, like if you have 2 cos and 2 sin, it's controlling the width of the radius, and if the numbers are outside or not being multiplied by cos and sin, it controls where the center of the circle lies. And the same again. Okay, and now I think that's it. I think we're coming to the end of the screencast.